Hi, welcome to 1LD first experiment. In this experiment, you're going to find freezing depression coefficient of menthol. To do that, you have to collect something called cooling curve of this menthol, right? And this is basically the setup of all you need. So first, you have a hot plate right here, right? Plugged in. It's pretty hot. And you have your warm water bath where you're going to melt your menthol or later on menthol solution, right? With cinnamic acid and stuff like that. And also you have water ice bath where you're going to cool your menthol to solid, right? And that's how you collect your cooling curve. So for the ice bath, you need more ice than water. So make it cooler. So the temperature difference from these two is going to give you a better graph in your cooling curve. Otherwise, sometimes people cannot really observe the latency heat if this one is not cold enough. If you do not know what latency heat is, you need to review that, right? So a couple tips for this experiment. First, the hot plate is hot, don't do this. I used to be a professional chef. We try this, we try this on grill to see what kind of food is ready to cook. So if you have never done that, don't do that. It's really hot. Second, because it's hot and we have cables, this one is actually from the hot plate by itself, and this is from temperature probe, right? If these cables touches the surface, you will be damaged. So we don't want to do that, right? Second, I know there's a lot of food have menthol in it. Remember, this is actually pure menthol. So if you have a really good sniff on this, it won't make you uncomfortable. So try not to smell it. All right, so come back to our experiment after this safety moment. We're gonna see that right now, inside is a menthol. The probe's right here. It's actually 67.9 degrees and increasing. The menthol melting point is around 36 degrees, so it's already melted. It's liquid, so good. It's all melted, right? That's menthol right there. All right. So to have a good cooling curve, of course, you're gonna set up your method of collecting, right? For me, right now I'm using 5 seconds per sample. Means every 5 seconds, I'm gonna take a reading of the temperature. And I'm gonna set up the time of duration is 300 seconds. Usually 3 minutes fine, but just to be safe, 5 minutes is recommended, right? Okay. Now, when I try to collect, right, I don't like to use this interface, but I use this one right here, with the second icon, which gives you the curve, right? You can see the curve while you're doing that. Some people does not have a really good collection of the curve because maybe they start collecting the reading before the probe even touches the menthol, so you're gonna see a huge jump and then start decreasing, right? So the ideal way in my experiment, in my experience, to collect this is start collecting when this one is still hot and in the menthol. And also, while collecting, so the important effect of how good this data is will be how uniform you collecting through your sample, right? To make you actually collecting the temperature reading from all over the sample, so this motion throughout the measurement is necessary. So let's give it a try. So right now, you guys ready? Unscrew this slowly. So right now my test tube is good to go. And then I'm going to start to collect the reading. Here we go. Awesome. That will be my first reading. And that change. See, when I change to ice box, right, I did not stop. So here we go. So the first reading is right here. The second reading probably somewhere in the air. So the temperature wasn't dropping that much. Okay, so why the temperature drops so quick? Huh? Anybody? Okay. Okay, so right now, I can actually feel some resistance on my fingertip. Why? Because probably the outer layer of the menthol are start frozen, right? And it's sticky. There we go. Alright, so the temperature reading start slowing down, right? Okay, so why the temperature change is leveling right now? Anybody? Why is the level? It's not like before, decreasing dramatically. Why? And what is latency heat? Okay, so again, I'm actually poking chunks right now. Basically, means that mass majority, if not 100% of menthol already froze, and the temperature starts decreasing relatively more dramatically again. The question. So right now, it's mostly solid form, right? Why is the temperature decreasing rate is slower than when it is actually liquid form before it reaches latency heat? Okay, so right now, you could stop the measurement because you already observed the latency heat really good, and right now we're going to the tail part of this cooling curve. It's 145 seconds, so it's actually lighter than 3 minutes. Since we're already here, we can let us go to the 3 minute mark and see what's up. See, the temperature decrease is actually linearly, right? It's almost linear. Why is that? Awesome. So right now it's 3 minutes. Now we'll just stop. There you go. And you can see the menthol right now is a solid, right? Of course, one time is not good enough. So if you want to repeat a couple times, just make sure you got the right data. It's recommended because the lab is not that long, and all you do is just go back to warm bath and reduce temperature. And that's how you collect the cooling curve of menthol, pure menthol. Later on, when you collect the cooling curve of menthol solution with other chemical also dissolving in menthol, the process is actually the same. However, the curve will be different. And then that'll be your job to figure out why the curves are different and what is the freezing point depression of menthol is. I hope you guys have fun in this lab, and good luck.